conservation of charge. Let's go back and talk about net charge for a second. So here are three different objects. The one on the top left clearly has more positive particles than negative particles, so it has a net positive charge. The one on the top right has only negative particles, so clearly it has a net negative charge. The one on the bottom has no net charge, it's electrically neutral. I realize if you actually count them up, they don't actually match, but this is a 3D object and you can't see them all. Bear with me. So to think about this, on the macroscopic scale, your body is full of electric charges. Not just a couple, but about 10 to the 29th. But your body is electrically neutral, right? You don't walk around giving off a static charge. So what that means is there's no excess of either positive or negative charge. Okay? In physics terms, if you add up everything, you have a net quantity. In this case, your body has no net charge. Conservation of charge. We've talked a lot about conservation laws. Remember, they always apply in a closed system. So here, in a closed system, total charge is conserved. Now, there's a couple of aspects to think about with this. Remember, charge is either positive or negative. So the total number of positive charges has to stay the same. You can't take a proton and make it magically disappear in a closed system. Same thing with your total number of negative charges. You can't actually turn an electron into anything else. And because at some point your charge has to come in multiples of that elementary charge, you only have fundamental particles, right, down to protons and electrons. There has to be some multiple of that. You can't have half of an electron. So your net charge may not equal the total number of charges in the system, but your total net charge is going to stay the same, all right? And you can only have multiples of elementary charge. That was confusing, so let's look at a sample problem, okay? This is actually from AP Physics 1 released sample problem, so hopefully this helps you out. Okay, in an experiment, you have 3 spheres, and then we have a net charge of plus 3e, plus 5e, and negative 3e. They're allowed to interact, and then afterwards, which of the following are possible values for the final charges? Okay, the easiest one to rule out here is B, all right? Remember, your charges have to come in multiples of the fundamental charge. 4.5 is not going to work, so we can say that B is out. The next thing to think about is adding up the total net charge of your system. So 3 plus 5 minus 3 gets you back to positive 5. So if you add up the values in each option, you should get back to positive 5. Otherwise, it doesn't work. So for A, plus 4 minus 4 cancel, and then plus 5. Hey, that one works. All right. What about C? Plus 5 minus 8, I'm at negative 3, plus 7, and that gets to 4. Nope, that one doesn't work either. And then for D, plus 6 is 12, minus 7, I'm back to 5. So here, both A and D are possible values for my final charges on the 3 spheres.